Okay, today we're going to look at some basic probabilities. So we're starting to our probability unit. So this first one, convert the following to percents. So what we're going to go ahead and do, remember that a percent is out of 100. So we're going to go ahead and move our decimal. The easiest way is to move a 2 to the right. So this would be 53%. Once again, we could do the same thing here, 2 to the right. And notice it doesn't always have to become an integer. This is still 0.3%, but it's now a percent even though it is a decimal. So a lot of times when we say like convert a decimal to a percent, like you think, oh, it shouldn't be a decimal anymore, but in this case it is. This last one, you have 7 divided by 20. I usually first convert it to a decimal first, so we get 0.35, and then I take it and convert it to a percent, so this is 35%. Okay. Our vocab for today is starting with sample space. So the set of all possible outcomes of an experiment is the entire sample space. So if our experiment is rolling a dice, our sample space is that you could roll a 1, a 2, a 3, a 4, a 5, or a 6. And if we have a specific event, it's the outcome of a chance experiment represented by capital letters. So maybe if we're rolling a dice, our event is that we get an even result. So which of those are even numbers? Well, 2, 4, and 6 are. So once we go ahead and we find those things, we've got the sample space, we've got an event, the probability is the measure of the likelihood of an event. So if we're looking for the probability of this event E, we're going to look at the number of outcomes in event E over the total number of outcomes. So this really here, when we say total number of outcomes, we're really talking about the sample space. And I think something to kind of note here is that a probability will be between 0 and 1. And if it's 0, it means it never happens. And if it's 1, it means it's always happening. Okay, so let's go ahead and start at the beginning here. So some probability experiments. First, we got spinning spinners. Answer the following questions using the spinner at the right. So notice we got numbers 1 through 8. We also have white and black that we're landing on. So if we're looking at the even results, 2, 4, 6, and 8 would be the even results. And there are 4 even numbers. Out of the total, there's a total of 8 possibilities here. So we have out of 8. If we are looking at the next one with black, we'd have, once again, there's 4 black spaces out of 8 total possible. Whereas if I said, hey, what's the probability of getting a 3, let's say, we would say, hey, there's only 1 3 out of the 8 possibilities. Okay. So let's look at the next one. Selecting marbles. A bag contains 8 red marbles, 12 blue marbles, 9 yellow marbles, and 11 green marbles. Let R equal red, the B equal blue, the Y equal yellow, and G equal green. Find each probability as a percent. Okay, so if we want the probability of selecting a red marble, we'd have 8 out of, and something you're going to want to know is the total. So if I take my 8 plus my 12 plus my 9 plus my 11, how many total marbles do I have? I've got a total of 40 marbles. So we're talking about 8 out of 40 for the red ones. Since I want this as a percent, I'm going to go ahead and divide 8 by 40 and I get 0.2. And then think about that as moving it twice to the right, so we end up with 20%. Remember here, you're going to kind of have to fill in that blank spot with a 0. Okay, if I look at the probability of green, I've got 11 green marbles out of 40. 11 divided by 40 gives me 0.275. Take it, move it twice to the right, I get 27.5%. And then finally, if we're talking about something that is not blue, it means it can be any other color besides blue. So it means it could be red, it could be yellow, it could be green. You can think about this 2 ways. You can either think about, so maybe I'll do it kind of over here on the side. but not blue, we could take our 8 plus our 9 plus our 11, or we could take just like the total of 40 and subtract away the blue. Either way, we end up with a total of 28 marbles. Okay, so we're going to have 28 over 40. 28 divided by 40 gives me 0.7. So take that and move the decimal twice to the right, and we get 70%. Okay. So now let's talk about a deck of cards. So a drawing cards have a standard deck of 52 cards. You've got 26 black, which consist of 13 spades and 13 clubs. 26 red, which are 13 hearts and 13 diamonds. Or you can also break it down. You could have 4 of each number. So you've got like 4 aces, 4 twos, 4 threes, 4 jacks, 4 kings, 4 queens, etc. Find the probabilities and leave your answer as a fraction. So if we want the probability of reds, we're going to simply have there's 26 red out of the 52 totals. You can either leave it like that, or remember on our calculators, if you hit math, enter, enter, this is equivalent to 1/2. Either way is totally fine, though. You can simplify it or leave it as is. If we're talking about spades, there are only 13 spades out of the total of 52 cards. If we talk about jacks, that's kind of like a number. So there's 4 out of the 52 cards. If we're talking about anything that's not an ace, so there's 4 aces. So there's 4 aces. So therefore, anything that's not an ace is any of those other 52 cards that aren't those 4. So you've got 48 other cards that are not an ace. So 48 out of 52. And last but not least, if you have a black queen, well, there's 4 queens, but only 1 of each suit. So there's 2 black queens out of the 52. Once again, you can either leave it as such, or you can simplify these. So this would be the same as like 1/4. This is the same as 1/13. 48 out of 52 is the same as 12/13. And 2 out of 52 is the same as 1 out of 26. Once again, either way totally works. Okay, so now let's think about rolling a 6-sided dice. If we want the probability of getting a 4, I should have probably said a fair 6-sided dice. We're going to simply have there's 1 option out of 6 total. If we talk about getting an odd number, well, 1, 3, and 5 are all those cases, so there's 3 out of 6. Okay, so once again, probability is going to leave as a fraction. You could write it as a decimal or convert to a percent. Oftentimes, I'd just say leave it as a fraction because that's going to be the easiest way. All right, let's continue on. A tree diagram follows the branches to the end to create the sample space. So as you continue all the way to the end, you're going to have all the possible options. Tree diagrams are useful when events happen in order oftentimes. The first level of branch shows the first event occurring, the second shows the second event occurring, etc. And we'll see another tree diagram a little bit later, but we're going to start off today by flipping a coin. So you flip a coin 3 times. Draw a tree diagram that represents the sample space. Okay, so the first flip, you get either a heads. I'm going to use H for heads or a tails. So this is your first flip. Then from that, you get either, the second flip, you get another heads or a tails. This is for the second. And then same for the third, a heads or a tails. 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 So you'll notice here by the third flipped that there are 8 outcomes in the sample space. And that's because as you count it, there's 8 things kind of there at the tail end. So if we want the probability of getting all heads, notice here there's only one option that gives us all heads. We only have HHH up top. Any of those other ones, maybe you get 1 or 2 heads or no heads, but you're not going to just have 1. So there's only 1 out of 8 chance of getting all heads. Okay, we can also represent things by a Venn diagram. So we have 50 students total, and they either use text or social media. 20 students said they only use text. So there's 20 students who are over here, but not in the overlap. In this middle here, it represents people who have both text and social media. Right? They do both. Okay. 25 students said they use social media. We'll come back to that. And then 17 students say they use both text and social media. So we've got 17 in the middle here. And then you'll notice that the social media, that's the entire circle. It's 25 students. So here we've got 25, but we already counted 17 that do both. So there's 8 that use social media. If you note for a minute though, 20 plus 17 plus 8, when I add all these together, I get 45. So there's 5 students that are missing. So oftentimes we write the 5 kind of on the outside, and it represents students who do neither. Okay, so let's go ahead and let's find some of these probabilities. So how many students use social media? There's just a total of 25 students who use social media, right? Because we have to look at, actually let's go back, let's make it text, because that'll make it a little bit more interesting. So if we look at that, there's both 20 students plus an additional 17 who use both, so we have a total of 37 students who use text. If we talk about students who do not use social media, we're talking about anyone who's not in that circle. So we've got 20 who are outside that circle plus another 5. So we get 25 students who do not use social media. And then what is the probability that a student does not use text expressed as a fraction and a decimal? So if we don't use text, we've got 8 that use social media only and 5 that don't use either. So not text. So we got 8 plus 5, so we got a total of 13. So we got both 13 out of 50. And if I divide that, I get 0.26, which as a percent is 26%. Okay, let's go ahead and let's look at this last one. So 100 people were sampled, and we have the following results, with the results below. We've got that they're male, female, lefty, or righty. And notice those are 2 separate groups. You're either male or you're female. There's nothing else. You're either lefty or righty. There's nothing else. Complete the following tree diagram. So first of all, there's 100 people that we sampled. So this thing right here we could say is 100. Okay. Maybe I'll write it on top just because it's a little bit bigger, a little small to see in there. So we got 100. Okay, if we look at the total of female, if we look at the circle over here on the left, is 3 plus 47. So we have a total of 50. Which means that there's 50 females, and this has got to add up to 100, there also has to be 50 males. Okay, notice there's some overlap though. If a female and a righty, we've got 47 people that are females and righties. So over here for righties, we've got 47 of them. For that to add up to 50 though, we'd have to do 50 minus 47. We get 3 people who have to be lefties. Okay, which means if there's, look at here on the diagram, this, okay, so this part was both F and R. If we've got another 43 people that are righty, that has to be that they're male. So then up top here, we'd have 50 minus 43, and we'd have 7 people who are lefty and male. So let's take a look at the wording now. If you randomly select a person, what's the probability that they are a lefty? Well, we've got 3 people that are lefty, as well as 7 males, 7 females and 7 males, 3 females and 7 males, out of a total of 100. So we got 10 out of 100 people. Okay, now let's look at the next one. If you are male, so we're just looking at the bottom portion here, what's the probability that you're a righty? So there's 43 people that are righty out of the males, which is a total of 50. This last one we'll call conditional probability. So we'll come back to that actually in 2 more lessons, but that's a good introduction for you. Good luck with your assignment.